Hi boys and girls, welcome. Today, your big goal after watching this video is to understand similar triangles and how they relate, and when you take a transversal line, how the different angles relate in this one. So let's make our essential question understanding angles better. So our essential question is going to be able to understand angles better. This first one's going to start kind of mellow.
There's a tree in the meadow.
It's just like when we measured the sign outside. We're going to kind of walk into this one, and the explanation here hopefully will make similar triangles make more sense.
How are we going to figure out how tall it is? We can look at its shadow and even measure it to find 4.7 meters, but still we don't know how tall it is. If we, however, look at our own shadow, we might find a clue. These are similar triangles. Therefore, their sides are in proportion.
Now, when he's talking about having similar triangles, that means that over here, this big triangle created by the shadow of the tree and the actual tree itself with a line connecting them is the exact same angles as you have here. Two similar triangles have equal angles. Write that down. Two similar triangles. That means same shape, different size. If they were congruent, they would have to be same shape and size. Because they're just similar, these are obviously, the person is not as tall as the tree. They're just same triangles, angles, same angles, different size. So as I look here, on this tree, there's a 90-degree angle here. This works great with right triangles. 90-degree angle right here. That means those two are equal, but that's not the only equal angles. They're all equal because it's similar. So right here, you've got a little angle here that's from the ground where the shadow is to the person's head, the ground where the shadow is to the top of that tree. Let's say this is like, I don't know, 50 degrees. This one like 50 degrees. They're similar. Whatever this one is the same as that one because they're two similar triangles. If this had a curved line here and a curved line here, that would be showing they were both angled or equal. Then you would have the same thing here, but this time you'd have two lines up top showing that the two lines here are equal to the two lines here. So let's say this one is like something smaller, and I totally didn't do any math here to add it up. I don't remember what I said. The other one was 50. 50 plus 90 is 130. So we're just estimating how much more to get to 90. Is that 50? So I totally didn't do any measuring here. Let's just pretend like this one's also going to get us that total of 180. So whatever this angle is here, yes, I know I need to have a total of 180, but I was just kind of randomly saying a number. So no, it would be 40. Because you need to get 180, and I said this one was 50. Because 50 plus 40 would be 90, plus 90 would be 180. So yeah, let's say that this one's 50, this one's 40. Adding those all together would give us a 180, but the point is that they're similar, that this angle up here is going to be equal to that angle up here. This angle down here is going to be equal to this angle down here because they are similar triangles. Let's just let him mellow you out because I'm totally killing the vibe here. Let's keep it going.
My height is 1.83 meters. My shadow is 1 meter long. The shadow of the tree is 4.7 meters. Can we find the height?
Now, he multiplies out on this one to get it using probably a calculator, but if you want to know how he's found that scale factor, you cross multiply and divide. You would take your 7.7 times your 1.83, dividing by 1 would give you your 4.7, and you would know what to multiply by to get this. No, I'm sorry. That would give you the answer, not the scale factor. He divided to find that. If you want to find the answer, you cross multiply and divide. So you would take 4.7 times the 1.83 divided by 1 would give you the 8.6. So finding the scale factor is actually that change here. And you would have had to divide 4.7 by 1 to get that change, which really works easy when this is 1, but it's not always 1. So be careful on that one. Cross multiply and divide to find your missing piece. Point of the story.
If I recognize that the relationship between my shadow and the tree's shadow is impacted by a scaling factor of 4.7, I can use that same scaling factor on my height to get the tree's height. Thus we can use proportion to use my shadow and my height and the tree's shadow to to discover the tree's height.
Now, again, this only works because those two triangles are similar, meaning they have equal angles. Now, you're looking at corresponding sides. This side corresponds to this side. When you get into shapes like trapezoids or where they have multiple sides that you're looking at, just make sure that you're comparing the two sides that are the same size of the triangle. You wouldn't want to compare the hypotenuse, this long angle, to the height. That would not be the same thing. You want to compare height to height, base to base. That long leg here, this hypotenuse, you're not going to compare that unless they give you those numbers, which they could have. Or we could solve it using Pythagorean theorem, which we're not ready for yet. We'll get there. All right, so that one was nice and mellow and chill. We've been talking a lot about corresponding angles, and I want to make sure everybody knows exactly what that's meaning. So let's jam out a little bit with a little bit faster video. We've got some more things happening here with angle properties. So here we go. Let's go a little further in this. Jamming out. Up to acute. Right angle. 90 degrees. Obtuse. Bigger than 90. Smaller than 180. Reflex. Didn't know that existed until this video. Never touch. They never touch. They don't like each other.
And there's only one thing that comes between them. Yes, a line that passes right through each of them. It's called the transversal, and it has several angle properties, just like these. Vertically opposite angles are equal. Corresponding angles are equal. Alternate interior angles are equal. Co-interior angles equal 180. Vertically opposite angles are equal. Corresponding angles are equal. Alternate interior angles are equal. Co-interior angles equal 180.
Right, 90. Greater than 90, less than 180. Greater than 180, less than 360.
Now before you try some geometry problems, you're gonna need some more knowledge to solve them. So listen closely up to these other helpful angle properties. The angles in a triangle or on a line add up to 180 every time.
Yeah, they do.
Angles around a point or in a quadrilateral are easy. They always add up to
360.
Vertically opposite angles are equal.
Okay, vertically opposite are angles. So 2 and 3 is also equal to 6 and 7. 2 and 3 because they're opposites. Now that also means 1 and 4 are equal and 5 and 8 are equal. It's as if you took this group of lines, 1, 2, 3, 4, is exactly the same as 5, 6, 7, 8. Now, we also know that a straight line equals 180. So they're saying that if I add 1 and 3, that's a straight line. But because 5 is the same as 1, you could also add 3 and 5, and that also equals 180, which is the next part of this.
Corresponding angles are equal. Alternate interior angles are equal. Co-interior angles equal 180. Vertically opposite angles are equal. Corresponding angles are equal.
Again, we know that this is the same exact thing as this group here. So that means 8 and 4 equal. Bam!
Alternate interior angles are equal.
Alternate interior angles are equal because we knew that 1 is the same as 5, which means 8 is the same as 4. So if you were to add those up, 1 and 4 would be the same as adding 5 and 8. Since 1 and 4 is the same as adding 5 and 8, you could really add 5 and 4. That's all they're saying.
Co-interior angles
180. Alrighty, boys and girls, great work on that. If you have any questions, please make sure to write them down. I want to get Avid style on this and start coming up with questions that you could have asked about these things that you just learned. Thank you so much, guys.